Section 2.8 is graphing linear inequalities in two variables. And whenever we're graphing inequalities, there's going to be some shading involved. So we're going to graph and then we're going to do some shading. First off, let's talk about solutions. The question is, which ordered pair is a solution to this function, 3x plus 4y is greater than 8? To find out which pair is a solution, you plug them in for x and y and see which one gives you a true statement. Whichever one is true is a solution. So if I start with A and plug in 6 for x and negative 3 for y, and do my math, I have 18 minus 12, which is 6, and 6 is not greater than 8, so that is not a solution. So you try 0, 2. Plug in 0 for x, 2 for y, and I get 8 is greater than 8. 8 is not greater than 8, that's not true, so that's not a solution. Check negative 2, negative 1. And negative 10 is not greater than 8, so that's not a solution. So let's hope this last one, D, negative 3, 5, works out for us. And it does. 11 is greater than 8, so this is a solution. So D is the correct answer. Since it gave us a true statement, 11 is greater than 8, that's true, then D is the solution. So let's talk about now the graph and what the graph looks like. We're supposed to tell whether each one of these is a solution, and we can plug them in and find out if they are or not. When I plug in 0, negative 4, I end up getting 8 less than 6, which is not true. So this is not a solution. And when I plug in negative 3, 8, I end up getting negative 31 is less than 6, and this is a solution. So now we're going to look at the graph to look at all the possible solutions. To start out graphing, you're going to graph what's called the boundary line of this equation. And the boundary line is where it's not an inequality, it's an equality. So I'm going to graph this line right here. The only thing that changed is the sign, and this is called the boundary line. To graph this, you can do it a couple different ways. Just a quick Algebra 1 review. You can solve this for y if you like. I'm going to do that over here. So I subtract 5x to the other side, and then divide everything by negative 2. And 5/2 is my slope and negative 3 is my y-intercept. And I can graph this line. I can also just plug in 0 for x and y and get the x and y-intercepts. If I do that, I plug in 0 for x. That means I have negative 2y to solve for y. I just divide and y equals negative 3, so that's my y-intercept. And then I put in 0 for y and get my x-intercept. I put in 0 for y, then I have 5x equals 6, so x equals 6 over 5, which is just over 1. So I put a dot right there. And I go to make my line. Now here's the trick. Look at your inequality. If it's greater than or less than, you have a dotted line. And if there's an or equal to, then it's a solid line. Because if it's or equal to, it can equal that, so you can have a solid line. Here we just have less than, so we have a dotted line going through these dots. The last part is to do your shading. So to do that, what you're going to do is just plug in some point on the graph, doesn't matter. I suggest you plug in 0, 0 because it's the easiest. The only time you cannot plug in 0, 0 is if your line goes right through there, which ours doesn't, so we can do that. Plug in 0 for x and 0 for y. When I do that, I end up getting 0 is less than 6. You're trying to figure out if this is true or not. Is 0 less than 6? Yes, it is. That's true. So that means you're going to shade on the side with 0, 0, because this is true. 0, 0 is a solution. So I'm going to shade everything on this side of the graph. So any point on this side of the graph is a solution. I can plug in any of them, just like I did negative 3, 8, which negative 3, 8 is right over here, and it's a solution. But anything over here, like we plugged in 0, negative 4, which is down here, is not a solution. So you plug in a point, and if it's true, you shade towards that point. I plugged in 0, 0 right here. It was true, so I shaded over on that side. Let's try a couple other ones. If I have the graph y is less than negative 3, I want to first graph my boundary line at y equals negative 3. At y equals negative 3, I go to negative 3, and it's just a horizontal line at y. Sometimes it gets confusing. You don't know if you're supposed to put a horizontal or vertical line. Your clue is if you draw a line and it's on the axis, that's wrong. Because if I would draw a vertical line, I'm right on the axis. I don't want that. I want everything where y equals negative 3. It's going to be a dotted line because it's just a less than sign. And to find out which way I shade, I plug in a point. I'm going to pick 0, 0 because it's easy. There is no x, so you don't have to worry about that. You're just plugging in 0 for y. The question is 0 less than negative 3? No, it's not. Negative 3 is less than that. So you shade away from that point because 0, 0 was not true. So I don't want this side, I want over here. So I shade below. Over here I have x is less than 2. So I want to draw my boundary line at 2. So I go to make a dot at 2. Draw my boundary line. This is less than, so it's a dotted line. Choose a point. I'm going to pick 0, 0. And again, there's only an x to plug in, so I have 0 is less than 2. Is that true? Yes, 0 is less than 2. So I'm going to shade toward 0, 0 because I want this side because this is where my solution is. So I'm going to shade over here. Last one we're going to do is throwing in an absolute value now. You know how to graph these, except now we're dealing with an inequality, not an equality. So the end result, we're going to have shading. That's the only difference. So if I go to graph this, I know it's going to be translated to the right 3 and up 4. That's where my vertex is going to be. So to the right 3 and up 4. 1, 2, 3, 4. This is my vertex. I know that's going to be flipped because I have a negative, and the slope is going to be 2. So I have to go down 2 and over 1, down 2 over 1. This is going to be a dotted line because there's no or equal to, so it is a dotted V. Now to find out where I shade, again, plug in a point. I can plug in 0, 0 because my graph did not go through there. If I plug in 0, 0, I end up getting, in here I have 0 minus 3, so the absolute value of negative 3. And the absolute sign just makes this positive. So I have negative 2 times 3. So I have negative 6 plus 4. My end result, I get 0 is greater than negative 2. Is that true? Yes, 0 is greater than negative 2. So I need to shade where the point is I plugged in. So I need to shade on the outside of my V. If it would have been false and I needed to shade away from, I would have shaded inside the V. So that's how that works with absolute values. You either shade outside the V or inside the V. So I want you to go ahead and graph this one in your notes. It's not an absolute value, it's just a line. and make sure you do your shading because it's an inequality.